Okay, good evening everyone. I'm Matt, KK4NDE. I'm hoping to have a copy of this. I bought a website, kk4nde.com. I'm going to have more information on what I'm presenting with a copy of this presentation, as well as there's more details on there about the other bits and pieces of the projects that I'll talk about on there. The topic is Raspberry Pi in amateur radio. Now, I should have made sure that this remote works. That's what happens when you don't test batteries. Okay, it is not this kind of Raspberry Pi sitting in your radio. It's not for snacks when you're contesting. That's the wrong kind of Raspberry Pi.
Is that PowerPoint?
Yep.
We're qualified.
I've got it. So Raspberry Pi is a lot like a conventional PC. It runs the Linux operating system. There is a version of Windows 10 Internet of Things that you may have heard of. I haven't played with that, but you would still be limited by it's an ARM processor. That's the language the processor understands. So you wouldn't be able to run, that's okay. You wouldn't be able to run, for example, your desktop applications that run on your normal PC. It has to be built so that it understands how to talk to the processor that's built into the Raspberry Pi. A computer would have one or more drives for storage. The Raspberry Pi has a single SD card for its main storage. It does have USB ports, so you could plug things in. Computers has one or more usually upgradable memory. The Raspberry Pi has limited memory. USB ports, it's mostly plug and play. Network interface, it depends on which Raspberry Pi model you get. There's a couple of them out there. Some of them have no network interface. Some of them have wired, some are wireless. If you have USB, you can plug in and add network if it's not supported. The conventional PCs are expandable with add-on cards. A Raspberry Pi, they have, it's called a hat. It's the same sort of idea. It plugs into some expansion pins on it. People have made control interfaces for relays or lights or motors, other various things. Conventional PC has an audio card. The Raspberry Pi, some of them have a audio out, but not a full audio card with input and output. You have to use a USB audio card or something else if you want input as well as output. But it does have configurable input-output connections for general turning things on and off, controlling things that a conventional PC doesn't have. You may have heard of an Arduino, which is another small development board. It's similar with some things, but it's a slightly different purpose. It's more of a single purpose. It doesn't run an operating system. It runs your embedded programming to do one task. I've done a couple projects. I built a repeater controller on one. It's good at doing a single thing and only one thing and nothing but that thing. There's less to go wrong because it can't do quite as much. But it's also less flexible in some ways. It's got integrated storage versus the Raspberry Pi where you have a whole memory card you can put files on and do things you want. They have a similar idea with shields you can plug on to add network or something. Unfortunately, I can't pass an Arduino around because I left it at home tonight. It looks a lot the same. It's just slightly different orientation of where the pins are to connect things. Yes? The clock speed is different between them. The Raspberry Pi, I have a slide in a moment. There's a couple versions, how many processors it has, what speed it is. The Arduino is definitely a much slower clock speed. But it's for very simple things where you just want to, say, detect that there's an input from a carrier-operated squelch that's high or low, and then turn something on or off based on that. It's very simple. You can write very simple logic into it without having to worry about maintaining a whole operating system and potential for things to crash or hang quite as much. Here's a comparison of the different Raspberry Pis. There's a Model B, which is somewhat outdated. I think I do have one of them here I can pass around though. It has 2 USB ports, 100 megabit network. This particular one, I added on top of it a RS-232 to TTL serial adapter. I was using it to control one of my first projects with Echolink. The box over here is a combined Echolink radio and a APRs iGate receiver, both running on one Raspberry Pi inside the case. I can pass this around if you want to see it and look at it. It's got a little Altoids tin box with the, if I drop enough pieces, with the little controller to go from the serial to the push-to-talk and carrier-operated squelch, and you can sort of see through the vent holes the Raspberry Pi, so I can pass that around. And it's also got hanging on there the USB sound card for the audio. There's also a couple of companies that make knockoff ones. This one is NanoPi Neo. It sounded really cool because it's supposed to have a built-in audio sound card. It's really tiny. It's really fast. I haven't figured out how to get the sound card working though, so to me it's not that useful yet, but it does work, it runs, and it sounds really cool if I get that working. And this is a newer Raspberry Pi 2, which is the successor to that model. And I also have, I'll pass around here, a Raspberry Pi Zero, which is a lot less expensive and a very tiny one. There's a few companies that make a USB port, a USB hub that you can plug in, so it'll power it and it'll run it, and it gives you full-size USB ports and other various things. So I can start these passing around different sides of the room here, if I don't drop them. You can see in at least a couple of them, there's a little micro SD card that's shoved in the slot for the memory. It boots up off of that and stores all its data and whatnot. There's two ways that you can have them run. You can have it boot up with a full desktop environment. After the presentation, I'll plug in the Pi Zero and show that to you. Or you can have it run very simple, a command line. That's what this one's doing. I'm not going to show that because it's not very interesting. It's just a login prompt, plain text. Projects. You can use it for a general purpose, like a mini computer or a mini server or a streaming box. That's not that exciting. The exciting part is linking it up to do other things. I was reading the other day, somebody had it hooked up using it for remote rig operation. And they were posting on Facebook about how they were doing that. Repeater controller, there's different software. Echolink controller. The software I use for this box is capable of being both a repeater and Echolink controller. It's very, I don't want to use the word complicated. There's a lot of settings that take a while to figure out what exactly they do, but it's extremely flexible. APRs Digipeater, I didn't bring all of the pieces for that, but the Pi 2, the bigger one that I was passing around, not in a case, I'm currently working on hooking it up to a FT1900 Yaesu radio to be a digipeater. I can actually pass around, I'll wait till that slide, I'll pass around the interface that I built to go between the Raspberry Pi and my radio. I've got some diagrams of that. APRs iGate for receive only. It's as simple as they have these $10 USB RTL SDR adapters. I think somebody did a presentation on one previously, the little SDR adapters. You plug it in with USB. It's actually designed to be a TV tuner, but people have figured out you can modify it and receive stuff and decode stuff. So just plugging in a USB device and running some software, you can do a receive-only APRs iGate for, 30, 40 bucks tops. And it works surprisingly well. It doesn't work quite as good since I'm in a bad location at my apartment, but it does work fairly well. I can show you afterward some maps on aprs.fi of where I'm hearing packets versus AE4ML, which is downtown in a much better, higher location. Here is a couple pictures of this Echolink Node. Version 1 on the left, I had just a stack of stuff, a power supply, a fan, and the radio, the converter adapter, and the Raspberry Pi itself. That wasn't so portable, and at the time when I wanted to work on 70 centimeter, I had to disassemble my car and tweak the levels and do a whole bunch of stuff, so I upgraded to this, which is a small computer case. I figured out the radio would fit in the CD-ROM drive, and it looks a lot nicer, it's a lot easier to carry around and move around, a lot more reliable too, because stuff's not getting bumped all the time. Here is a picture of the APRs digipeater sitting on my desk. This runs off to a J-pole antenna that's on my wall, but it's just the Raspberry Pi, this little board that I can pass around now.
How many watts does that J-pole handle? What are you running into that?
Right now I have this set at, I think it's 10 watts or 20 watts. I can't remember. I'm keeping it down because also this is my desk and our craft room, and I've got people above me and below me and beside me, and when we go and work on projects, we're 2-3 feet away from it. I don't want to cook us. But it seems to work good, and afterward I'll pull up the maps and show what my coverage is, hearing packets directly versus the downtown digipeater. It's really simple. I've got a couple diagrams, but audio with a little bit of isolation and a very basic board for push-to-talk. In this little box, I'll pass this whole box around. There's a little bitty board that you can hardly see that's a full serial breakout. I haven't gotten a chance to test that one. What I currently have been using is one I had to solder onto a little pin and kludge it together because they, for some reason, didn't break out CTS and RTS. They broke out CTS and DTR. And the software I'm using uses CTS and RTS pins from the serial port to control the radio. So I'll pass this around. You can see what those are. I standardized on simply using 3 separate headphone connectors. One of them for the speaker that goes into the back of the radio here. It just goes over to the interface. And one of them for the push-to-talk to ground, and one of them for microphone to ground, and that goes into the front of the radio for the audio and push-to-talk connections. And this fell apart. It's very prototype-like. It's just push-in connectors. But I'll pass this around so people can see that. Interfacing a SDR, as I said, it's USB. You plug it in. That's all there is to it. It's a software-defined radio. It does everything for you. You don't have to build anything. SDR, I don't have a picture of it. I should have brought one with me, but it looks like a thumb drive with an antenna connector. It's not terribly interesting or exciting. Interfacing to a radio, it's very similar to a TNC. You have an audio input-output, push-to-talk, and maybe carrier-operated squelch signals. This Echolink Node, one of the reasons I'm using a Yaesu FT7900 is on the back it has a connector for packet that includes the carrier-operated squelch. So I'm not having to do Vox or something funny in software. It very reliably picks up when there's a signal and drops when there's no signal. There's a couple of solutions. You can use a commercial interface, Signalink or something. Or if you don't want to spend a bunch of money, you can do what I'm doing and homebrew an interface. The little red serial boards that I got run between $10 and $20, depending on which one you get. If you want to get it on the slow boat from China, you can get it for $3 or $4 instead of 10 or 20. Then the audio isolation transformers I'm using, a couple bucks on eBay, or you can scavenge them from something. For the Echolink Node, I actually just went and picked up at Walmart or Best Buy some of the car iPod aux-in ground loop isolators, and they seem to work well. As I said, the commercial...
Used to have an ice audio transformer, 600 ohm in out. No more.
I actually did find on eBay somebody that was selling a few of them, and that's what the board I'm passing around has on it. The commercial all-in-one solution, I've heard that a couple people say the signal links work well with Raspberry Pi. I don't have one. I can't prove or disprove that. They're expensive. You plug it in and it works. That's not exciting. As I was saying, a few different ways you could do isolation. The one-to-one transformers, the little Altoids tin that's going around, there's a couple of ceramic disc capacitors for isolation in it. I've seen a lot of people use resistors. Well, it's not for a Raspberry Pi. I've got this cable that is for connecting a cell phone for APRs droid to a Chinese Baofeng or TYT or Kenwood style radio. All they did is they just put a couple of resistors in line between the microphone and speaker. That's all they did for isolation. There's a couple different ways to do the push-to-talk and carrier-operated squelch if you build it yourself. On the Raspberry Pi, there are these general input-output pins. That's the 2 rows of a whole bunch of little pins sticking out on there you saw. It depends on the application support, but it's a bunch of 3.3 volt inputs and outputs. You can program them to do whatever you want as long as your software supports it. That's actually what I'm using on this Echolink Node here. It connects in with a couple of transistors and resistors and a Zener diode. It works well, but it's a little bit finicky to figure out the settings because I discovered between the different versions of the Raspberry Pi, the pins aren't exactly in the same place on a couple of the versions, and the documentation is kind of hit or miss as to whether they go by numbering on the board or numbering in the chip or something else that's, I'm not quite sure what it is. So it took some trial and error, and I want to come up with something better. I think I have, and I'll go into that. There's built-in serial on the GPIO port. Some of those pins are a standard serial input-output, like for a debug connection at 3.3 volt levels. There's a couple more of them that can be set to alternate functions to act as the CTS and RTS and other standard serial pins. However, there's a small issue with that. They're by default set up as a debug console, so you have to disable that. And also, at boot up, the alternate mode of the pins isn't set up, which means with that early version of the Echolink setup, when I was using that with the serial port on top, if the Raspberry Pi crashed or while it's booting up, it defaulted to the wrong state. It wasn't high or low as it was expecting it to be. So the radio would come on and key up and not unkey until somebody went and power cycled something. That's not really desirable because you don't want things to just run away transmitting if it fails. It would be nice if things fail and shut down instead. I think I found, requiring an extra piece of hardware, the little red board, a nice middle ground. A dedicated USB serial adapter with CTS and RTS built into the chip. It can be hard to find them for some reason with CTS and RTS already brought out. A lot of the advertisements that I saw said CTS RTS, but when I looked close or when it actually showed up, it was DTR, not RTS. I don't know exactly what DTR is, but it's not what most of the software uses to key up.
Data terminal ready.
Okay.
In the old days, that was programmable on the control
I believe it is,
register.
but the software, apparently the software that I was using didn't use the data terminal ready. It used the, was it ready to send? So I was hoping to find something that was plug and play. The board that's in a little baggie does have the RTS pin broken out, but I didn't get around to soldering little connectors on there and putting it together to test that yet. It's on my plate to do, but life is busy. What can I say? The nice thing here is, since it's an actual serial chip, when it first gets power, it defaults to its idle state, which is just sitting there not trying to do anything. That means that the radio is not going to key up if it's sitting there idle until the application connects and says, I want you to flip this to a ready mode, and changes the state of the pins. So that's a lot nicer, because when the program crashes or while it's booting up, the radio is just sitting there doing absolutely nothing, which is an ideal situation. If something goes wrong, you want it to shut down, not go nuts jamming stuff. Here's a rough block diagram of what I'm doing with the digipeater. I don't have a carrier-operated squelch on this. It's just open all the time, and the software that I happen to use listens and it filters out the background static from the actual signal, so I don't worry about squelch on that one. I used this same sort of a diagram for the first Echolink node. It used Vox to detect when someone was talking. You could add in another layer here that would have the carrier-operated squelch go out and go through whatever level shifting logic to feed back into here and go back into the program. My applications that I've done the last couple times just haven't needed it, and it didn't make it into my diagram as a result. For audio interfacing, I used a USB sound card. You saw that going around. It just has the standard 1/8" jacks. To connect to, I was using the outermost pin and the innermost pin, the microphone and ground, and one of the speaker channels and ground. Some software, you have to specify if it's the left or right speaker channel. Other software just kind of puts it out there and it doesn't matter. It requires reading some of your documentation with whatever it is you want to use. And then, my best case, feeding it through a audio transformer into the radio or vice versa.
May I ask?
Yes?
Your Echolink, have you actually been out connected with other links?
I have. When I'm at home, I've connected to the N3NO system. Sometimes I've been carrying on a conversation on the way home, and I kind of fall down and get where I can't hit any of the repeaters. So I can control it with DTMF tones and link it into another system. And people can remotely connect into that. After this, I'll try and demonstrate that real quick. I think I should have internet. For running this, I've actually taken this with me as far out as, I think it was Arizona to a Comic-Con. And it's in a carry-on compliant case. And it went through, didn't have any problems with TSA or anything. On the way back, one of them asked, "What's all that?" And I said, "Oh, it's my radio. I'm a ham radio operator. If you want to see my license, it's underneath that." They went, "Oh, that's cool," and went to the next person. I guess that's one of the reasons I wanted to try and make it look clean and neat, because let's face it, if I go back here, which one of these looks a little bit scarier? The one with wires all over the place, or the one that's just a computer cabinet? As one of my friends pointed out when we were up in convention, this kind of looks like a mad scientist went to work. And the computer case, it's a computer case. Everyone knows what a computer case is.
If you're a ham, that one on the left looks a lot more benign.
Yeah, this is true. I guess it depends on your target audience.
Real deal on the left too.
But it also makes it a lot easier because the radio is recessed in here a little bit. The knobs don't get bumped. I can have a little screen in here that tells me if something's not working. It tells me the IP address it's on so I can try and remote into it. It tells me the status of the services. I've got a little button here I can push and it'll reboot the services so that if something's wrong I can just hit a button, try and just reinitialize yourself. One of the things that the Raspberry Pis don't have is a power button. You have to either log into it and tell it please go shut down, or what I did is I put one of the case power button across one of those input-output pins I talked about earlier, and there's a little task that runs checking whether it's high or low. When you push the button, it sees it goes to ground, and it initiates a system shutdown. And then the display goes on shutdown, and it prints out, I think, terminated or something, and you give it like 10 seconds and the lights all stop blinking. It makes it much easier to troubleshoot and a lot cleaner looking. Also, I have a couple screws that the antenna mast can just clip onto on the back. It's a self-contained unit. You can just pick it up and the whole thing's there. For internet, I use a Verizon Jetpack because hotel Wi-Fi seems notoriously unreliable at places I've gone. And they like to block a lot of ports, and Echolink requires you have certain ports open. If I bring my own internet, I know what I have. And it's USB, so there's no wireless to get jammed or anything.
How do you like the Jetpack? I just got one about a month ago.
The Jetpack seems like it's been very good. I've actually had 2 of them. This one's slightly newer and does the, I think they call it like XLTE or something. It's supposed to be more streams, so it's faster. It seems more stable. The older one seemed good too. There is a mode I learned. When I first got it, it could do either Wi-Fi or USB tethering. And there was a firmware update that allows it to do both at the same time. And it actually shows up as a standard Ethernet interface in the Raspberry Pi. So as far as the Raspberry Pi and Linux is concerned, it's just a wired network interface. It doesn't know the difference. There's no configuration or anything like a cellular modem you'd have to set up for your carrier. It plugs in and it looks just like a wire to the operating system. I do actually have on the back here a standard wired Ethernet port. So when I'm at home, I can plug into my regular network and not have to worry about adapters or anything. I also have an HDMI port, so should something go horribly wrong, I could plug it into a TV or something and figure out to debug it. Interfacing to a radio, USB with the CTS RTS, I just use an opto-isolator. It seemed the simplest and easiest thing to do. That little USB board, actually the RTS signal when it's idle is 3.3 volts. When it goes and gets toggled to set by the software, it goes down to ground. So the way that I resolved needing to, with the parts I had on hand, I needed it to be the other way. So I got thinking, if I just use an opto-isolator, I can go from VCC to that. When they're both 3.3 volts, it's off. When this goes down to ground, it turns on and it completes a circuit. I stuck a little LED so I could tell if it was on or off at a glance. And then I can connect it to the radio ground and push to talk so it grounds the push to talk. I don't have to worry about signal levels on my radio. The push to talk pin rests at 8 volts. That wouldn't be too good feeding into the 3.3 volt controller chip, so it avoids all of the issues with the isolation. So yeah, there's actually 2 versions of this. I put 2 values because you can get these in 5 volts and 3.3 volt varieties commonly. The one I got happened to be set to 3.3 volts. You can change it to 5 volts with a solder jumper. I didn't see a need because both of those would have the same level issues with my 8 volts that I'm hooking up to on a radio. So I just picked values of resistors that were appropriate. I have these diagrams up on my website, so I forgot to print out. I was going to print out little cards that had the website and some other info. But if you want to send me an email, if you look me up on QRZ, I have a valid email address on there. My website at kk4nde.com has a bunch of information about all of these various projects I've mentioned with more detail. While I didn't do the carrier-operated squelch on the digipeater, I did do that for the Echolink Node, and I believe it works the same way on the serial interface board as what it works on the GPIO. In my case, the radio, I believe, went low for when a signal was detected and sat there at 5 volts. It was a 5 volt or 0 volt signal. So I just used a simple run it through a resistor and have a 3.3 volt Zener diode to make sure it's compatible with the 3.3 volt levels on the serial chip and the Raspberry Pi, and it keeps everything happy. It didn't seem to need any more complicated isolation than that. That seemed perfectly adequate. I didn't have the ground path shared because it was already shared. They were on the same power supply, and so ground was shared through the 12 volt power supply on the radio and the 5 volt power supply to the Raspberry Pi. They were already on the same relative ground. This just keeps it so it's 3.3 volts relative to the Raspberry Pi, and whatever the radio's feeding in is high or low relative to that. It seems to work.
Pull the CTS to 0?
I'm sorry?
I said that's enough to pull the CTS to logic 0?
It seems to be because the ground, you could connect a ground across there. I was afraid I'd end up with a ground loop because the ground is shared on the power supply as well. It seems to work well enough pulling it to 0. I don't have, when I was poking around in this, I didn't have much issues with the grounds being at different levels. Everything's very tight and compact, and all the connections are close together, so that may have helped me. For hardware, the 2 serial adapters I passed around were from SparkFun. They're a company that has, you can get small quantities of stuff for mostly reasonable shipping. If you want to buy a gazillion of them, you could go to some place like DigiKey and order them in bulk, but I've had bad luck where I want to buy 3 cents worth of product and it's $30 worth of shipping, and that I'd rather pay, $5-10 for the product and $5 for shipping, and I still come out ahead even though the product's a lot more expensive. The SparkFun products are also available for a slight markup on Amazon. If you're in a bigger hurry and you have Amazon Prime, you can get it next day or whatever for a small price more. The USB sound card is just a cheap generic USB sound card off Amazon. It was one of them. I did a search for Linux compatible USB sound card and picked the most popular one, and it worked. Nothing special about it. I know there's a whole bunch of them out there. That was just the one I happened to pick. That's a lot of stuff with the hardware. The software, there's a lot of stuff out there that I haven't seen. There's a lot of things out there I've played a little bit with. It depends a lot what you want to do. I've used, for the operating system, I use Raspbian, which is the Raspberry Pi Debian variant. It's there. If you buy a Raspberry Pi, it's there. Hey, this is our default recommended operating system. And I have, by default, the USB serial converter and USB sound card took a little bit of figuring out to identify where they are on the system. So I wrote them down so I don't have to figure them out again. that wasn't terribly fun trying to figure it out by trial and error, so I want to make sure I don't forget what they are. APRs software, I've used this Pymon APRs, if you can say that, good luck. It's for the USB SDR. It's fairly simple. You tell it, here's what the frequency is, here's what my APRS key is, here's where I am, go listen, and it goes and listens. Then for the digipeater, I'm using, it's APRX, that's not a typo, I don't know why exactly it's called that way. And then APRX is the control software that does the digipeating, and then Sound Modem is a software TNC thing. It converts the sound card into a network interface that the APRX software transmits and receives data over. It seems like it's working fairly well so far. I'm hoping to get it all working in a nice, neat package and then figure out where I can put it to have a better coverage and better signal. I haven't worked that out yet, but I got to get it working good first and in a nice package first. For repeater and Echolink control, I use Echolink. It's a configurable software. It can be a duplex repeater, a simplex repeater. It can run Echolink. It can have mailboxes. It can have remote receive sites and voters and remote transmitter sites and links on and off between multiple repeaters and all sorts of complicated interconnected functions and features. I just have it so it's a simplex radio interface in the software, one receiver transmitter, and then Echolink for the internet side. I don't do anything fancy with repeating and stuff. Incidentally, at least the Echolink software, you can use a USB SDR receiver as a receiver. So if you were making a repeater and put enough filters or got a higher quality SDR, you could use just a SDR and one transceiver to build a repeater with that software. I thought that was kind of cool, but I don't think it's cool enough to go and spend money on buying a duplexer and filters and all that just so I can learn about it and play with it, because that's a bit of an investment. I did have it working briefly within my room. The signal was horrible because even at 5 watts, the transmitter was horribly desensing the receiver. What is this, a foot away from it? But it did work. It was a nice proof of concept, and it was an interesting exercise. So it's useful in that way. You can still experiment with it and learn stuff. Open Repeater Project, I haven't used it, but I've heard a lot of people online seem to like it. It's another repeater controller software that's free. You can set it up to do all sorts of things, control repeaters and whatnot. Digital modes, I've heard good things that Fladigi works with a Raspberry Pi. I haven't tried it yet. I may try it because that sounds like an interesting prospect. I have a couple extra Raspberry Pis laying around, and my ICOM 7100 just plugs in with one USB connector. If it works the way I'm led to believe online, that would be really cool to just plug in one USB cable and one network cable and be able to sit on my laptop remote doing data stuff. So I think I'll look into that soon, but I haven't done it yet. And that's the end of my death by PowerPoint portion. I can try and do a couple of these demos real quick. Before I do that, let's see, the Pi Zero, I was going to show what this looks like. Actually, if you leave that on for a moment. USB. And unfortunately, due to the size of this thing, it requires an adapter to go from micro HDMI to normal HDMI. To power this, I'm just going to use a cell phone booster battery pack thing. And I should probably plug in the wire here before I connect power.
Before you get too far along, look under that wheel. You've got something.
Lens cap.
Oh, that's your lens cap.
Yeah, don't want to lose that.
You don't want to run over that one either.
No, that wouldn't be good. And my keyboard here. Yeah, I have a roll-up keyboard somewhere. I couldn't find it, though. This works well enough. It's a very nice keyboard. I got it for $1 at a yard sale.
That's the best kind.
It needed a little... someone had spilled coffee on it, so I washed it off in the bathtub. Popped the screws off, popped the cover off, scrubbed it with some soap. It's good as new. It's the best keyboard I own. It's probably a little hard to see, but should scroll some stuff. It does a normal boot up thing. It says it's starting all these services in the corner. After a minute, it should come up with a desktop or a login screen or something.
This is the Linux that's coming up right now.
Yes, this is Raspbian Linux with a full desktop. It's the same operating system that's running on here, except it's with a graphical interface. So it's, if you've, normal desktop computer type effect, you can run programs. Unfortunately, I forgot my USB hub, or I'd plug in a mouse, but you can pull up a web browser. Pretty much anything you can do on a low-powered computer, you could do on that basic browsing. They have some repositories of common programs. Some people use them for streaming video and whatnot. I don't find the desktop as useful because it uses a whole lot of memory. I prefer to use a command terminal interface, and once things are working, I usually don't have to touch it, so I don't have to worry about what command does what very often. Let me see if I can get this Echolink to work. So I've got this radio that's tuned to the frequency this is listening on, so I should be able to ask it to go into tell me what its ID is.
Activating Echolink. Local node ID is 25 51 45.
Okay, so it's connected to the internet, and that ID, if you were on another Echolink station or device, you could connect to that and talk over the radio. I should have Googled or written down what one of the other connections is. I could probably look that up very quickly, though. I was going to show the maps on the APRs. So there is a map of roughly where Fredericksburg is. The purple is where there's more packets that I've heard directly, and the red is where there's fewer, and where there's no color, I haven't heard any.
Timeout. Deactivating Echolink.
Seems like it has not too bad of a coverage right in town and a little bit to the north. By comparison, the digipeater that's running on a real radio has better filters. I live right by the NOAA weather transmitter, so better filters certainly make a difference. And the 2-meter radio is hearing quite a bit more. And by comparison, this is AE4ML, which is on a building somewhere downtown, up much higher than what my little apartment is. And so,
Is that NOAA machine the 6255 zip? You know?
it is 162.425 megahertz.
Okay.
And I think it's 300 watts from the hospital. I think it's somewhere on the roof of one of the hospital buildings. I haven't figured out where exactly, but it's close enough that all the cheap SDRs and like the Bofeng radios, I can simultaneously listen to the NOAA Weather Service and hospital pagers at the same time as any repeater or simplex conversation. Yeah, it's without having to retune, you can hear them. It would get very interesting when the fire department used to be on 2 meters. I could simultaneously listen to the K4TS repeater, fire dispatch, hospital pagers, and National Weather Service without retuning the radio. But I don't recommend using a Bofeng radio for working the marathon on 2 meters downtown. But that's the general difference in the coverage. Considering that basically this can be achieved with a $10 USB adapter, some free software, and a computer that runs Linux, I don't think that's too bad. And a couple hours of your time setting configuration up. Let me see if I can find N3NO Echolink. You can tell I've done this search a few times.
Is RS-232 still widely supported? Like 16 years ago, program office I was working for was trying to buy every 232 card they could get their hands on. Because they've been superseded, or they came up with something hotter.
It seems like it's used a lot for radio stuff, mostly because it's super easy to say, make this pin high or low in software. It's gotten much more aggravating because new computers, all they have is a USB port. It's extremely hard to find a new computer that has serial ports. And if they do have a serial port, it's usually on a header or something. Two of the big issues I've seen, most of the adapters that I've found are Chinese clones of stuff. And there were issues with prolific. You have to find an old enough driver for the fake chips. And that's getting harder because, especially in Windows, they work fine in Linux, but in Windows, Microsoft is enforcing driver signatures more and more, so you can't install the old drivers on a new machine. The other is FTDI, and the issue with FTDI is at one point they released drivers which would actually render fake chips inoperable. And it was really hard to tell if you had a fake chip or a real chip until you had a brick. And then you knew you had a fake chip. I think the breakout board I passed around was FTDI, and the other one that I had to solder onto was a chip that it was like a 340G or something. It's a generic chip that I have not heard of before a couple weeks ago, but it seems to work well under Linux at least.
Cut short, we got about 4 minutes before we have to leave.
Okay. I guess any questions?
Excellent presentation. Thank you very much.
Okay. And if you want a lot more information, go to my website. I've got across the top. Somebody brought this to one of the field days. I don't remember who it was, but I really liked it and I took a picture of it. But if you go to my website, kk4nde.com, hobby projects, there's a bunch of things for different Raspberry Pi projects that I've done. And it has diagrams, explanations, all sorts of stuff. So lots more information. Thank you. Thank you for having me.